This is our industrial grade do-all bandsaw. It has a lot of different features that I'd like to take and point out to you at this point in time. Right up here, this is the speed calculator for depending on what kind of material you're cutting. You're able to spin this around and you locate the type of material that you have, and it will, based on what you're trying to do with it, it'll tell you what speeds that you should be running it at. This is a speed indicator over here. Our bandsaw is equipped with a low and high range, okay? And this is a speed indicator telling you how fast you're going. Up here is our data safety information about the saw that the person can read before they get started, indicating to them the different features of the saw, what cautions should be taken when using it. This here is a cutoff tool for cutting off the blade, because we buy our blade in roll form and then we cut the blades in length to fit the saw. This is our saw welder down here. This is what we use to weld the saw blades together, and then we grind the welds after we weld it. So this is equipped with a welder and a annealer and a grinder all in one, so that we can make bandsaw blades to fit our saw. As we go further down the machine, we have our dust collector right here at the bottom. This is our dust collector right down here. This tube goes on up the side and on up. We could turn this on and it would create a vacuum system within the saw itself to get rid of dust and debris that we don't want to be in contact with. Down on the very bottom here is a feature we just have no need for at the time. It is a pedal for having an auto feed system. This is an older saw, so it had a gravity weight kind of auto feed system that would help pull your block through your saw up above, and it would work off of a pulley system. We have disconnected it because in our shop we just don't have a need for that whatsoever. We're going to take a little tour now around our bandsaw to the side of it so we can see a few features that are over there. On the side, what we have is two different levers that are very important. This is to run from our high to our low range, okay? And this is our speed control mechanism. This can be adjusted only here down for faster or slower in whatever range you're in above when the saw is actually running itself. You would switch the gear here when the saw is in the off position, and then you would take and adjust this up or down to make the saw run faster or slower. On the back side of our saw, we have sort of a little area where we keep all of our push blocks and our vise for round stock, our brushes to clean and saw, and saw after we're finished with it. Up above, we've installed just a board so we can hang our extra saw blades on. Like I said, we have a variety of 3 blades that we use to cut our materials with. The blades are the proper length, but they're in different teeth configurations and number of teeth per inch, depending on how thick the work may be. Also, one other feature that our saw has available, I'll see if I can get down and show it to you. We have not had a need to use it, but our saw also, this table can swivel right up here. So right in this section here, this particular component can be loosened up and this table can be put in at an angle. And that feature is very important of years ago when they used to do die work. Like I said, I'm a journeyman tool and die maker. And what you could do is take a block of steel and you could bandsaw the block at an angle, and therefore you could cut your punch out of the same material that your die is. And that tilting feature came in very handy in making tooling of years ago. 2 other features that is on this bandsaw is right up here above at this particular location is a knob that you would turn. That in turn would allow you to take and raise and lower your guides. Then you would lock it back in place. Once you had it in the proper location, you would lock this back in place. Another feature on the saw is right under here is a hand crank. This hand crank is used to adjust for the wheel, so you can tighten and loosen the saw blade. You would open the door up here like so. That would expose the upper level of the saw, and then what you would do is you would come down here and crank on this hand crank one way or the other, and that would take and raise or lower the saw blade to loosen it so that you get the saw blade in and out. At our bandsaw, we keep a variety of different push blocks, you might say, to push the material through the bandsaw blade, and we're going to go ahead now and get started. Generally speaking, down at our shop we have 3 different saw blades that we have available at our bandsaw for cutting various types of materials and thicknesses. Generally, it's a rule of thumb to have 2.5 teeth on the work at any given time so that it cuts without doing harm to the bandsaw blade. As you can see by this example, that there is not 2.5 teeth to cut something this thin with this heavy of a blade. So what you'd want to use is a blade that's something like this if you were going to try to bandsaw this, so that you would have at least 2 to 2.5 teeth going through your work, and it would make it cut much smoother. Okay? By the same token, at the extreme, you know, even using this as an example, as far as the teeth goes, it's just barely at 2.5 teeth on the work at any given time. You would more so want to use maybe this blade here to cut through this material to give just a little more teeth on the work at a given time. And here again with this particular part, same holds true. You could get by with this, but it wouldn't hurt anything to use this one. But like I said, 2.5 teeth is the rule of thumb that we use within our shop and try to maintain. We are now going to begin to cut the material necessary in order to make the students' projects. We pre-mark all of the rough stock with layout lines so they know where to cut it off as they begin to make their project. On a bar of this length that sticks out past the table, it's an acceptable practice to grab a hold of the bar thusly on this kind of small of a diameter in order to cut this off. So you could hold it here, push on here, and begin to cut that off. This bandsaw is going to have a tendency on any round stock to want to grab a hold of it and spin it in this fashion. I will demonstrate how that's done in just 1 second. If this bar was just sitting like this and we were going to cut the bar, we'll turn on the band, put it to where the mark would be approximately, lower the guide down to an acceptable height. We can bring that guide down further, okay? And generally speaking, the further the better. But we want to see what we're doing. So it's acceptable to have it just a tad taller so that we can see what all's going on there with the bandsaw blade. The ideal height is just above the work, but here again, with all the safety guards on there, we have to see what we're doing. So if we were to turn this on, and we were to push like this, you can see the condition that it would come under. It would try to make it spin, so you have to be mindful of that. Okay? When you're doing a bar on this length, I will show you 2 methods. One method is how you hold your hand out here to keep it from spinning. You never want to hold it on something by grabbing the end like this. That's bad juju, okay? What it is sometimes there's a burr on there, and if this should catch it and spin that bar, it'll just slice you to pieces on the palm of your hand, okay? But it is not beyond normalcy to take and line that line up, take your push block. If you spin the block this way, it makes it difficult to see the line because you can't see the line over the top of the wooden block. So we trim our blocks down on the back sides so that we can use them in either direction and we can see what's going on. Turn on the bandsaw, you grab a hold of it snugly, line it up, take our block, don't put your hand up here to push with, keep your hand back here at all times so that you don't slide up the block and put your hand into the blade. Line it up like so. Push on it like this. We must hold the material firmly in our hand to keep the part from spinning like we discussed before, but there's also, as the material starts to cut off on the back side of the component here, what it's going to want to do is, instead of pulling it this way to spin it, it's going to have a tendency to grab it and pull it this way to spin it. So as we go through the work, you want to hold on to it, push. As you see, when it broke free, it spun this part. That's what I was talking about. When cutting round diameters, which do not stick past the table where you can comfortably get a hold of it somewhere other than just the end, we use this vise here in order to keep the bars from spinning in the saw itself while it's doing its job. So what we do is we take the vise and we flip it over like this, putting it in the vise itself upside down and flat on the table. We go ahead and have our layout line up top where we can see it. We have enough distance between here and there, or the blade up high enough so that this handle here that we use for up, raise, and lowering the guide can clear. Any one of those combinations would be acceptable. So we tighten this up snugly in such a way that this doesn't interfere as we go across, and then we can take and saw this material off. We have the guide up just above. I'm going to lower this down a little. Now, we can also, if we should so wish, and if we want to put the guide closer, we could slide this out a little further past there, as the main objective is just to keep the bar from spinning and to keep the vise itself on the table. So then we can take and go here and begin our saw cut from this way. We can take also and come up here to the top and loosen our handle, lower our guide down to where it's closer to the work, tighten our handle back up to snug it up, okay? Making sure that our air is adjusted properly close to where it needs to be to blow the chips away. Secure a push block from the back side of the machine, okay? And we're ready to go. As you can see, we have square bar stock that's about the same size, but we do not use the vise in order to hold on to it because the shape of itself makes it where it won't spin when the saw blade is going through. Any kind of flat material on the bottom will keep it staying put as long as there's nothing that sticks past the top surface, like if it was a piece that had an angle on it or something like that. So this can just be pushed through just like this through the saw and without a problem. But this, on the other hand, would be an issue because it'll spin because of its round diameter. So we'll fire the saw up. Again, we won't use this side of the block, and as you can see, I don't have it up quite high enough to clear our push block. So we'll loosen this, raise it up some so that our push block can clear. Spin this around. This is the side we're going to use so we can see our layout line. We will turn our saw on, line our line up, and begin pushing through. Like before, I'm going to point out that we're going to break through this edge here. When we do, the vise itself will keep this from spinning, but this, you'll see, as it cuts through, will go ahead and revolve counterclockwise or back towards us. Done. Take and loosen our vise up, slide our material out. There you go. When cutting our low carbon steel or cold roll steel bar for our hammerhead, we'll check the speed indicator on the dual saw. As we rapid travel up to it, we can see that on low carbon steel, right here, which is what we have, our surface feet per minute should be between, we're 5/8 diameter, so we're between 1/2 and 1 inch, should be between 165 and 300 surface feet per minute. As we come over to the speed indicator on the machine, and we're operating presently in the low range, we can see that we're running right just under 175 feet per minute is the speed that we're running at the present time. Because this machine is set up with a variable speed lever, we can crank this up faster while it's running to a higher RPM or a lower RPM. Now we're going to begin the process of cutting up the square stock for the hammer head. Here again, this is a steel part versus the aluminum part we just got done cutting, and we're going to cut it off right there at the layout line as well. We'll turn on the bandsaw. Here again, the block this way will be too much, so we can't see, so we'll use this side of the block. Lining up the line, we'll take and come in, put our hand back here on the back of the back, keeping it from sliding. If it's up here, it may have a tendency to slide up and into the saw. As you can see by me cutting, this particular material is in there at a slight angle like this, okay? The reason for that is this particular blade is not new, and part of what they call the set is a little worn on one side, which causes the blade to want to go a little bit in another direction. So in those particular instances, we sort of compensate to keep the blade going straight by putting a little more pressure to one side or the other to take and make the blade stay going straight through the work. So the blade is not any good, it's still a good blade, you just have to compensate just a little bit for the, like I said, the set, which is the spacings of the teeth like this. One is a little more worn down, which causes the blade to curve around like this, one side or the other. We'll start it back up and we'll continue our cut. Now the noise that you're hearing, where you hear a click every once in a while, that's where either the weld is in the bandsaw, where it hasn't been quite smoothed out as well as expected, or the saw blade is missing a tooth. So when a saw blade is missing a tooth, that way what you're doing is you're hearing that one tooth that's missing as every time it comes around the blade in the same spot, it's giving that click noise. But this saw blade also has a combination of narrow and wider teeth on it, and depending on who welded the saw blade together, there may be not an exact match where narrow teeth are together with narrow teeth as the blade is welded. One of the things I want to show you is it is better to spin this block around so that we cut it with this end so there's more surface area on the work as we're pushing it through, versus this end where all the pressure is down at the bottom. That could give this block a tendency that when we get down to the edge of this part, that this block will kick up and flip like this in the machine as we cut through the final cut as it breaks through the outside. The machine is also equipped with this little air nozzle which blows on the chips to keep the chips away so we can see the line as we're cutting through the work. Again, what we're doing is having this bar just a little bit at an angle to keep the blade going straight due to the poorness of the condition of the blade on one side of the set. But that is still, like I said, doesn't make it an unusable blade. It just makes it a blade you just have to compensate a little bit for with your saw cut. You can sort of steer that blade through by pushing and pulling here on this bar, one direction or the other. I want to show you where my hands were when they were out of the view of the camera. My hands were actually both back here together, pushing on this way, okay? The stock is of reasonable length. I knew it wouldn't fall off the table once we broke through, and I could take and get even pressure with pushing like this instead of trying to push just like this. And we went ahead and cut the stock off. Over my career, I've had the privilege of working with a lot of skilled craftsmen that were specialists in their given areas of expertise. Some of them were like filers. I worked with a guy that was an expert at filing because he worked at a department that's all they did all day long was file. So he taught me a lot about files and filing. This is our standard mill files that we have within our shop. We have a variety of files, but we keep one of these at every machine so a person could deburr their parts as they went along with their project. We also keep file cards at each one of the lathes so that they could get this file card out and brush their files out at any given time. This particular brush is only to be used on files and nothing else, not to clean the machines or anything like that. Okay? The way you would use this brush is you'd look at the grain of the file, which direction it's going in this particular case, this way on this mill file, and you would brush with the grain to clean all the debris off your file. It is important not to put your hands on your file because the oil from your fingers would get on the file and cause it not to work as well as it could. So you brush your debris out of your file thusly as you go down, and if you take and there's anything that gets stuck in your file, you use this side with these alligator teeth to get in there and dig it out and get your file clean. It's got a file here that's just a little cleaner than the other. We're going to deburr parts. On our particular block that's came off, as you can see, there's a burr on the block itself right there, and we're going to get rid of all the burrs on the block. Anytime you machine a block and take it out of the machine, you deburr it before you do any inspection work. So you take and you go like this, and as I'm going, you can see how I'm working the file around the edge to make it smooth. Then you just move it to another location, make it smooth, move it to another location, and so on, all the way around the block. Okay, spin the block over. Deburr it, making it smooth, deburr it, making it smooth, and so forth. And you can see the direction I'm doing. Now, you can also take the file and run it across the top of the work like so. You can tell by the dicum, which is that blue colored stuff here, where that file is actually rubbing. You can see that it's touching there and there, the two high spots on this. These files are actually really good at being able to pick up the high spots on a given block. We're just going to run it around because you can see there might be stuff stuck to the material or just debris or a burr sticking up or whatever. So we're just going around the block on the semi-machine sides that are not finished, but the parts of them as it comes off out of the factory. The saw cuts are a different story. We're going to not mess with them as far as cleaning across because it would be kind of useless. Okay? Same holds true with our cold roll 5/8 bar. We're going to take and go across it like that and get it cleaned up. Spin it over. Okay, run down it to make sure there's nothing on it. Now the round one's a little more trickier. This one's got a burr on it as well where it cut through. I can feel it right here. So I'm going to go around it like this, and I'm going to rotate the bar as I'm going. And I'm changing the angle of it. Now this bar is nice and smooth on the end, right on the end.